So for the practice quiz for 13.1 to 13.4, I gave you basically 4 problems where, you know, they're kind of like, moderate level problems. However, if you're able to do these problems and understand the premise behind them, then you certainly can understand the material that's going to be on the quiz and perform well on it. So I'm making this recording to kind of go through it so that, once you've taken the quiz, you can check your results and see if there's anything you might have left out and anything you need to review a bit more before you take the real version of the quiz and, so you can be ready for it. So the first question that you were given was this figure here, and you were asked to find the area of it. Now, this is not a typical figure. You can count the number of sides, and they'll come up and say it's a 7-sided polygon. We don't really have any steadfast rules for them, even if it's a regular polygon. There's 7 sides, which it isn't. We'd have to break it down into triangles and see if we could find apothem or any other information that would help us figure out the answer to it. But anytime you're given a figure, like, it goes beyond any formulas that you have or the ability to break it into what would be equal triangles. You're going to need to break it into other pieces. Now, I'm going to draw some auxiliary lines here. This is not the only way you could have broken this down. I could have just drawn a line across horizontally, along that 3-inch side, and created a rectangle and a trapezoid as well, and still get the exact same answer. So, also keep in mind that sometimes, as you get some of these figures drawn here, there may be some information that might be left out, but you can easily figure out. For instance, one of the things that it's kind of left out here is, I really don't know the length of the base, and I'll try to show it here. I really don't know the length of this base here, which I might need as I do the area of the triangle, because I'm going to need to know that area. But, like, for instance, one of these 2 measurements might have been left out, in a problem. As long as I know the entire length up here is 12 inches and I know from here to here is 5, I can figure out from here to here is 7. So keep an eye out for those sort of things as well as you go through your material. There are some things I need to keep in mind here, and that's or label here. So I'm going to label these. This was pretty easy. That's, from here to here is 7 inches, here to here is 7 inches because it's the same distance as this here. This is being a rectangle the way I was setting up. I know this side and this side have to be 7 inches. This being another rectangle, this and this are 3 inches. And since I know this has a total of 15, I can deduce that this is 5. So you got to look for measurements like that to kind of help you. And what I have here now, and the way I separate it, is I have 1 triangle and 2 rectangles. And I'm going to find their areas and then, of course, add them together. So this area is going to be 1/2 the base times the height. Since it is a right triangle, and only because it is a right triangle do I have a base height pairing. If I don't have a right triangle, then all I'm going to really usually know is the base, unless they gave me the height as a measurement. And I have to make sure that's shown by showing me that whatever I have as my base, I have a line segment that's drawn perpendicular to it and passes through the vertex of the opposite angle. So, but this being a right triangle, the 2 legs are a base height pairing, so I could certainly do that. This one here is going to be base times height, which is 12 times 7. And this one's going to be, its base times height is going to be 7 times 3. So what I have is 17.5, 84, and 21. If I add those together, I get 122.5, and I have to make sure to put the square inches at the end. And in this unit, please be careful. Make sure you are putting units, the correct units in, because that can have you lose points from time to time if you don't. The next figure you were given to find the area of was this kite. You're still expected to know characteristics about a kite, but there's certain things about this one we have to figure out first, because right now the only length I'm really given is that this side here is 8 inches. However, I do know like on a kite, its diagonals are perpendicular, What I have here is a 45-degree angle, which means if this is perpendicular, I have a couple 45, 45, 90 triangles. And with this angle here being 60 degrees, I'm going to know that this being a right angle as well, I'm going to have some 30, 60, 90 triangles. Knowing that, I'm able to figure out some of the other lengths. For these triangles up here, the two 45, 45, 90 triangles, well, one of the legs is 8 inches, so the other leg had to be 8 inches, which means that these two lengths are 8 inches apiece. And since that's going to be also the side of a 30, 60, 90 triangle, that would be the shortest side because it's opposite the 30-degree angle, which means from the center to the bottom tip here, that's going to be 8 times the square root of 3 inches long. So now I know the measurements of my diagonals, and that's one of the ways that we could find the area of a kite. I mean, I could find the area of each of these triangles, and then, find the area of this triangle up here and double it, find the area of this triangle here, double it, and add them together. That would give me the area as well. But basically, the shortcut is I can use the formula. The area is 1/2 the product of the two diagonals. Now I have to make sure I measured the entire diagonal. This diagonal here is 16 inches. This diagonal here is going to be 8 plus 8 square root 3, whatever that total ends up being. So I put those numbers into the right plots, the places, and then I evaluate it, and that's approximately 174.85 square inches. For this one here, they ask about the areas and things like that. This was only asking about the ratios at this point. But, the fact of the matter is, I don't necessarily have to be able to find the entire area of one or go through the process of using a formula for the figure. These are quadrilaterals. I mean, they kind of look like trapezoids, but I don't know if that's for certain. I am told that they are similar, which means that when I see corresponding sides, they should all have the same proportion. Now, those proportions will carry over to the perimeter, and those proportions will help us figure out the proportion of the quadrilateral's areas. And that's what sometimes will let me answer the question. If I know the area of one of the figures, I can figure out the area of the other one without having to go through a long process of figuring out, finding all the pieces that I need to use the formula. So for this instance here, they just want us to write a ratio of the quadrilateral's perimeters and the ratio of the quadrilateral's areas. For me to answer that question, I start off by finding the scale factor. Now the scale factor, I mean, it depends on how you want to handle it. The scale factor in this case here is going to either be 3:7 or 7:3, because when I take a ratio of 6 and 14, that's what I get. It depends on, whatever you do, make sure you're consistent. So if I'm going from smaller to bigger, make sure that you consistently do that so that you can keep track of which one you're going to be finding next. So when I say here, what's the ratio of the quadrilateral's perimeters, from the choices that you're given on the online quiz, 3:7 was the one that you were given. 7:3 could also have been an answer, but that wasn't one of the options you were given. The other options were not any ratios that could be represented between these two figures. Now, so the ratio of the quadrilateral's perimeters is the same thing as the scale factor. So there's no change there. Now, when I look at the ratio of the quadrilateral's areas, well, the ratio of areas between these two figures would be the square of the scale factor. So, in this case here, if I'm looking at a 3:7 ratio for my original scale factor and ratio of perimeters, when I square that, I get a 9:49 ratio for the ratio of quadrilateral's areas. Now from here, if I was told like the area of one of these figures, I could figure out the area of the other figure just by using that ratio right here to appropriately to figure out what the answer should be. One of the other skills that we learned about in this particular section was to find the area of a regular pentagon or regular polygons in general. sometimes it depends on the information you have. Here, what we have is we have an 8-inch side, and that means that all the sides are 8 inches. And we're given that this measurement from the center to a vertex is 6.8 inches, which that's a radius of this regular pentagon. So one method I could use to find the area of this pentagon is to kind of continue this on, knowing that all these sides are 6.8, and figuring out that all these angles here are 72 degrees. And I know that's 72 degrees mostly because of the fact that I know that those 5 angles should total 360. All those 5 angles in the center should all be the same measurement as well. So when I take 360 and divide it by 5, I get 72 degrees. Now, at this point, and I'm going to show this in method 2, I could just use the law of sines at this point. Not the law of sines, the formula that we learned about with the law of sines and law of cosines, to find the area of one of these triangles and then multiply that by 5. But that requires you to kind of go through the methods, and in my course I did have my students go through some of those methods to make situations like this easier. What you can also do is I can draw an altitude, this apothem, in here. Now that apothem, if it's going to be an altitude of one of these triangles, it's going to split this side into 2 equal parts. It's also going to split this angle into 2 equal parts. And from that, I can actually use a trig function, or the Pythagorean theorem for that matter, to figure out what the apothem is. And that's what I'm going to show here. I can figure out the apothem as being the square root of 30.24, or about 5.5. I would use the square root of 30.24 just to be safe. And now that I know the apothem, I know the side of the triangle, or pentagon. If I know the side of the pentagon, and I know it's a regular pentagon, so all 5 sides are 8 inches, I can figure out its perimeter pretty easily. Therefore, I can use the formula 1/2 the apothem times the perimeter. And plugging those values in right here, I get about 110 square inches. Of course, the other method I could use, and I kind of alluded to it before, kind of starting the same way, is, I could also, find the apothem by using a tangent of 54 degrees, because that's what these 2 angles down here would be, because they have to total 180. I know these 2 angles have to be congruent because the 2 sides opposite them are congruent. I can figure out that A is going to be 4 times the tangent of 54 degrees, which is going to be about the same amount. And then the area of the triangle down here is going to be 1/2 8 times 5.51. And then, of course, I can multiply it by 5. I get about 110 square inches. So there's different variations you could do. And as I said, I could even have, just at that point, once I found the apothem of being 5.51 inches, I could have just done 1/2 the apothem times the 8 times 5 and gotten the same answer. So there's different variations you can do with that depending on how you see the figure, what information you actually do have, and make sure that you're using the right formula for the right circumstance. But that's all I have for this little review of this practice quiz. If you have any further questions, please contact me or your math teacher. But until I see you in a live lesson of my own, or if you're one of my students I get to talk to you on the phone, I will see you around. Have a good day.